So, welcome to the second video in our course B08 on data visualization. Here we're going to introduce ggplot. So, ggplot will allow us to visualize complex data sets more effectively. ggplot was developed first by Hadley Wickham, who wrote a very effective document PDF that's available in the course files for you, a layered grammar of graphics that kind of built on the grammar of graphics by Wilkinson and Burchin previously. And this was a consistent syntax for making diagrams by describing the different components. And our focus can be on making nice plots and tweaking them rather than writing code. And its central premise is the idea of layers. So we take our points and then we take our plot type and we put our points on the plot type like layers like that. So here we have two different layers in effect that we put these points on this particular plot shape. There's many different coordinate systems that can be used in these plots, and it's very scalable. So you might have different points, and once you've read them in, we can rescale them on different coordinate systems very easily. You can see here an example here where we take the classic caret diamond dataset in R, and then if we scalify a linear graph versus a log graph, we can see different things, a log graph, different things going on. So we can also do things like visuals, and we later will use a package called ggAnimate to visually show data as well. So all this is quite possible. ggplot has coordinate systems, and graphically you can think of that we've got our data and then our plot type, and we can place our data on top of our plot type. We can add things like we can change the aesthetics and change our point type or whatever, depending on what we want to do. So it's very pliable. It just is a different way of approaching coding than we've engaged with before. So we have ggplot, the original function, and then we add a plus sign at the end of that function, at the end of that line, to note that we're adding more. And that's the first layer, and we're going to build on it to add more. So that plus sign means we can add another function. So some sort of geom function, geom point or geom line. And inside that, we'll put in some sort of mapping of what the points are, which is X and Y, and so on. And what we're trying to plot here, maybe colors, for example, as well. And then we can map further things onto that by putting a plus sign at the end, such as the coordinates, the facets if we have multiple plots, a theme, a scale, whatever we want. And you see for the final part, whether it's two lines or many lines, we put our final plot has no plus at the end because we're not adding anything further onto it. So that's more simple. You can also note that if you're trying to save these plots, gsave is a way of doing it. So saves the last plot in your history out. You can scale the plot width and height. You also need to think about the file name, file type as well, if it's PNG, PDF, or so on. Aesthetics have a range of different options. You can color them by different colors and fill them. So it could be red, or it could be using the codes. You can change the line type from just a simple line to one that's dotted or dashed or both. You can change the other features as well, such as the size and the shape too. There are also graphical parameters that you can add on. So you could have things that you want to add in here, such as a curve, a path, a polygon, for example, if you're trying to fill an area, a rectangle. There's other things you can add on as well. Line segments, so you could have ab lines, which we'll use that function a bit. A H line is a horizontal line. V is a vertical line. There's also segments and spokes too. So there's quite a lot of different functions that you can use to represent different line types. There's also discrete plots as well. You can, if you want to do a bar chart. So you sort of see examples of them here. So you got a GM ribbon plot, so showing the area across this this kind of x-axis. We've got a polygon if you're doing close photometry, you're trying to select something. We've got a segment of a line here. You've got a GM rectangles, maybe you're selecting areas in a geographic area. There's different complex arrangement of spokes here. And then there's an outline showing maybe there's a threshold that's of relevance for your data set. It's a path, so you could be tracking mosquitoes flying around an area. And then there's a curve if that's the sort of model that you're dealing with. So ggplot can manage single variables. So here we might have, for example, a histogram with a bin width specified, or you can deal with two variables, where we have the aesthetics is indicating the two different variable names. So it might be two different columns in a data set, for example. If we read them into the ggplot function already, which might be an E, then we might not need them directly inside the second function because they might be known already. So that's the example we have with gmplot there. We'll also use smooth here, which is fits a linear model to our data set too. So you can see here we've got areas where you got some sort of frequency distribution. That's the same for the second plot, and to an extent the third plot. We've got a histogram instead for the fourth plot. We've got a dot plot for the fifth plot, and then a bar plot for the final one there. For more complex distributions, so discrete or continuous distributions, we can do that. Well, for example, we use box plot as well, and a variation on that that's maybe more effective in certain situations is violin plots as well. We'll also use jitter, the jitter function a lot to spread points out if they're all masked together. So jitter and box plots are kind of different options for doing the same thing. We can also do more complex distributions. So we can do 2D plots where maybe we just want to show an area that's of interest in some sort of 2D graph. So you see here we've got labels attached into this graph. We've got a dot plot type count there. We've got a classic point distribution in this plot. You've got an area that's of interest in this 2D plot. Quantile plot here, density plot here, text plots here, text added here. There's very many different options, as you can see. There's continuous functions as well. So we'll use line to visualize distributions that are talking with each other. And then we can also do things like visualize error as well. And there's really diverse options here. I can't say I've used any of these myself before directly because there's so many options for different things to do to plot. You can also do discrete distributions, maps, 3 variables as well. So there's quite a lot of options there. So you can see there we can do 3 variables by plotting x versus y with z mapped over as the contours. Or maybe we can do that as a raster plot as well. We can use stats, summary stats maybe that we're looking into if we're reading in a bigger data set into ggplot2, and that builds on more layers as well. We can also use scales to normalize our data in a particular way or scale them in a particular manner that makes sense for us too. There's also different coordinate systems. So you might use, for example, polar coordinates, or some sort of geographic coordinates if that's relevant for you. Positional ones as well. So you might have a geom point, for example, where we are jittered that to keep the points from overlapping each other would be an example of that. There's also themes you can use. So there's a black and white theme to make it more simple in terms of the colors. There's also the theme classic, a theme minimal. If you want to minimize the chart junk, that might be added in there. There's a dark theme as well, and a light theme too. Labels, there's many different labels. You might want to add a legend or axis labels. So axis labels you can do with labs, the labs function. So you just do a plus and then labs and add your text in the same manner as we have here. So you can see that all those things will be added on. We'll use the function annotate later as well to annotate text onto a graph. That sometimes can be useful if you're doing things repeatedly. And what else? Faceting. This basically takes a bunch of different variables that maybe have data associated with each of them and creates plots for each individual one. So that means you've multiple plots grouped together as well. And we look at how that works. So it's an additional function. So facet wraps, and we put the criteria by which that we want to separate out. So it could be a list of G names, for example, and we can put that in there at the end into that function to separate those ones out. Another aspect of faceting is scaling as well. If you want things to have to be adjusted for each particular plot, or to be the same for each plot. So ggplot, as you can see, basically there's 3 things we want to put in there: the data of interest, the mappings of it for the plot type, and then the actual plot type itself. So often this we shorten this to as few as 2 functions, but sometimes you might need many different functions to be put in there. And we can see how we can gradually build that up to get each one working first and then build it as we go along. So we get this kind of format ggplot, and we have our data, we have some sort of mapping, and then we have some sort of additional function at the end to represent what we're trying to show. We can add other things like stats, facet for multiple plots, different coordinate spaces, labels, themes, and so on too. So we might get something like this: ggplot something, then so GOM, facet wrap, theme, and so on and so on and so on. So what we looked in the video is the structure of ggplots. There are many diverse options available, and the general aspects of their data structures. You're likely to maybe use 10% of these functions over the next year. Don't expect to use many of them, but it's good to be aware of them if you're trying to represent your own particular data sets. It's good to look through them all. Please see the next video where we'll continue this discussion.